Welcome back. We just finished up discussing the practical math foundation with you, Craig.
Mm-hmm.
Let's see. Just tell us what comes after that, honestly.
Well, Kevin, the practical math foundation is all that any student really needs if they're just going to go into a non-professional technical career. So that's where a lot of people stop. However, if a student wants to go on to college, in particular if they want to go into a STEM career, science, technology, engineering, or math, then they're going to need a lot more math. So the first thing we do after Tier 2 is we take them into what we call Tier 3. Now Tier 3 is their next level up of math, and it's designed to get them ready for the SAT.
Okay.
Even though they may not want to be a science or math major or engineer, they want to do well on the math SAT because they want to get a scholarship or get into a good college. And so we teach them just enough math to do well on the SAT. Now, the way we do that, we start using now a textbook. In fact, it's the only calculus. Now, as a matter of fact, this is the only textbook that we ever use in our program, all 10 tiers. This is a book by George Simmons, and we have a discussion of it on our craighane.com website.
I understand it's a very cheap textbook.
Yeah, you can buy this book from Amazon for about $15.
Oh, okay.
And this book has all of the algebra and geometry and trigonometry that you're going to need at the high school level. Generally speaking. As a matter of fact, it's only a 120-page book. It's just amazing how much is in it. Dr. Simmons was a brilliant math teacher. And I used to teach a course in advanced mathematics and what's called topology and modern analysis out of one of his advanced textbooks. And when he came out with this in 1988, I got a copy of it and read it, and I was amazed by it. And in fact, I went out and bought a bunch of copies of it and gave it to students that were struggling with math, and it helped a lot of them with math. But it's really not a self-study book. It really needs a teacher for most students to go through it. Now, in the Tier 3, we only do about 30% of what's in this book, because they don't need an awful lot of the math that you need beyond that. And then, also in Tier 3, in fact, in Tier 3, we don't do any more geometry and trig than they've already done. They don't need that for the SAT. Then we have a special section on just how to prepare for the SAT, for the math SAT.
Like some of the tricky questions on there and things like that.
Yeah, the SAT is a tricky test. You really don't need to know that much math content, but what you need to know is a lot of little tricky stuff.
Oh.
And you need to know how to take a test, the techniques of that. So we have a whole section on preparation for the SAT, just so you can score high on it. Now the truth of the matter is you could get a perfect score on the SAT and still not be prepared to go to a good school. You could score a perfect score on the SAT and go off to, say, MIT, and there would be international students in your class that knew so much more math than you did that you would feel like you were a dummy because you're not prepared. So that's what we do in Tier 3. Now, if a student wants to go and study science or technology or engineering or math, STEM they call it, S-T-E-M, then we put them into Tier 4. Now in Tier 4, once again, we're going to go through algebra and geometry and trigonometry. Remember, they've been through it twice now. They had their first introduction to it in the Practical Math Foundation.
Yes.
They've had a little bit more of it now in Tier 3, getting ready for the SAT. And now we're going to give it what they're going to really need if they're going to go into STEM.
Okay.
Now we're going to go through this book completely and thoroughly, and we're going to add a lot of material that's not in this book. Because this book was written in 1988, and today there are modern tools that make the learning and the practice of math so much different. There's a tool called Wolfram Alpha that was introduced in 2009. It's actually sort of a free version of another powerful tool called Mathematica. It was developed by Steve Wolfram in 1988, oddly enough, coincidentally the year this book came out. And it revolutionizes the way you do math, even in analytical geometry, conic sections, the graphing of functions. It's just revolutionary. And so we introduce it in Tier 4. Now, Tier 4 takes most students about a whole year to go through because it's that much in depth.
Okay.
They're going to learn all sorts of things that they're going to need in STEM. But once they finish Tier 4 and learn how to use the Wolfram Alpha tool, they're going to be so much better prepared with pre-calculus math than any U.S. students are today, because this is not being covered in high schools today at all, the way it should be done. Then, in Tier 5, we do calculus. Now that is unbelievable. The way calculus today is done by scientists and engineers with these tools is revolutionary compared to the way it used to be. In fact, every calculus book today that's used as a textbook is obsolete. Graphing calculators are obsolete. Let me give you an example. Back in 1972, what we were teaching all of the engineering students was how to use trig tables, how to use logarithms and log tables, how to use something called a slide rule. That was really the tool they used. And math teachers in engineering schools earned their living teaching those subjects. In 1972, the first scientific calculator came out. It was the HP 35.
Yep.
Overnight, it obsoleted the stuff they were teaching. You never use a log table again. You never use a trig table again. You never use a slide rule again. They all became obsolete. You can't even buy them today. I mean, you can't even buy a slide rule. They quit making them. Because the calculator was so much better.
Oh, wow.
Oh, it was like 2 orders of magnitude better. Problems that would take you 30 minutes to do with the older technology, you could do now in 3 minutes. I mean, it was amazing.
Yeah.
It's just like, why is the practical math foundation so effective? It's because it's calculated. This is a much improved version over the original,
Yeah.
but it's the same principle. By the way, the original scientific calculator, 1972, in today's in dollars today in 2015 is about $2,100.
Wow.
That's what it cost.
Wow.
In 1972. It was $395, but that's equivalent today to $2,100. Okay. And by the way, how do I know that? Wolfram Alpha. That's where I found that out. Okay. Well, it's still, at $2,000, it was such a time saver, it was a bargain. As I said, our ancestors 100 years ago would have probably given who knows what, a fortune to have a tool like this.
Yeah.
Because they just made them so much more effective. Okay. Now, Mathematica was introduced to the world in 1988. It, again, was a game changer. It revolutionized things, but it was expensive and not accessible. You had to have a computer. In fact, it would only run on the Apples and the Next computers when it first came out. You couldn't even run it on PCs. They weren't powerful enough. And but it revolutionized the way that professionals were doing it. Well, then in 2009, Steve Wolfram made Mathematica, the parts you need for available on the internet for free. And so now today, you use Wolfram Alpha to do calculus in ways you could never do it before. And in fact, it makes the practice of calculus orders of magnitude easier than it used to be.
It's a very visual tool, right?
Oh, extremely visual, extremely practical. It lets you do things that manually would take you an hour to do, if you could even do them, instantly. And it does things that you can't even do manually. There's all sorts of calculus problems that you can't do with the manual techniques that are taught today. So they have to rig the problems up so that you can do it. They can't give you the real problems that you're going to get in engineering and science, because those you can't do with a lot of them with the techniques. But Wolfram Alpha you can. So you got to learn that tool. So we introduce it in Tier 4, and then we use it heavily in Tier 5 in calculus. Today, a student can learn all the calculus they need to go to MIT and Excel in a semester. Not 2 years, in a semester. And it isn't going to take a big thick book. It's just amazing. Then in Tier 6 we do differential equations. That's an extension of calculus that is the workhorse in modern industry. And we do that in Tier 6. We also teach them how to do all sorts of things out of a subject called linear algebra, which is all intermingled in this. So that's what we do in those upper tiers. And that's how you got to learn math. You want to learn it in layers. And you go deeper and deeper as you go up.
Okay.
And you don't want to go any higher than you necessarily have to. If you're not going to be a scientist, engineer, or go into math, then those are things you probably are not going to want to learn because they're hard. They're pretty difficult.
Yeah.
I mean, you have to, the higher you go, the harder you have to work. It's like you learn to play golf. It's pretty easy to learn to play it just as an amateur if you're not too good. But if you want to become a pro, it's a lot harder.
Yeah.
You got to really go into it deeper, work a lot harder, practice a lot more, and learn to use the tools that you need for a sport, for example. So that's what it's all about, and that's what we do in our upper tiers.
I like it a lot. So for Tier 3, that was really more of like, the test prep. Tier 4, getting into those STEM sort of, topics.
Yes, it's pre-calculus for STEM majors.
Yeah, really sort of making that foundation nice and wide so that you can have a higher peak.
That's right.
Yeah.
We do about 30% of this book in Tier 3 because you don't need very much. Okay. In Tier 4, we do all of this book plus a lot more. For example, I teach them how to think about complex numbers, which is rarely taught today in any high school, the way it ought to be. We teach them to start using Wolfram Alpha to do all sorts of things, conic sections, the way we treat them, and things like that. And then we continue that on, and then in Tier 5 in calculus is revolutionary. The way we teach calculus today is totally different and vastly superior to anything they're getting in any regular calculus class, either in high school or even in college. Even the colleges haven't adapted to it yet. They're still using the standard classical calculus textbooks. And you know when those things were actually created? 150 years ago. I mean, the real ideas behind it, that what's in a calculus book today is really any different than what we taught out of 50 years ago in the calculus books. They've had graphing calculators, which, by the way, were good technology in their day. They're obsolete today. Why are they obsolete? Because Wolfram Alpha does it so much better and quicker.
And that's exactly what you incorporate.
And that's what we do. So we bypass the obsolete technologies that are no longer being used. I mean, no engineer or scientist is going to use those old-fashioned techniques that are obsolete and time-consuming and difficult. They're going to use the modern tool. And that's what you want to teach people, the modern tools. I mean, and that's what we do.
It's extremely effective, honestly.
Well, it really is. It's revolutionary. And if you are interested in educating your child to go off to MIT or Michigan or Indiana or Purdue, or a good school, Caltech, wherever, this is the way you want to do it. You don't have to use my program. You maybe can find another program that does it. I don't know any others that do it. Maybe you can do it. I mean, if you really know math really well and you know these tools, you can teach it yourself, although very few people do. And I don't blame the high schools. They're caught in a trap. It's a time warp kind of deal. They're dealing with an older technology that hasn't been updated yet. It hasn't caught up. So I don't blame the high school math teachers at all. I mean, they're caught in the same trap. But that doesn't help your student any. And I'll tell you, the foreign students aren't caught in that trap.
No, not at all.
Because they take their very cream of the crop of their foreign students, they put them in very special classes with expert teachers that are up to date, and they use the tools. And so the foreign students come over, and they're ready to go. The international students. And our poor American students then have a real tough time keeping up with it. And it's not their fault, because students are students. They're equal intelligence anywhere in the world. I mean, it isn't the Chinese or Indian students are smarter than American students, or vice versa. Students are students.
It's just the training programs.
Yes, but it's what you teach them and the tools you teach them to use.
And I understand, like, beyond Tier 6, you have some higher sort of, like, more mathematical...
We do, strictly for potential math majors, and believe me, that's topics for another discussion.
Okay, awesome.
But we do. There's 4 more tiers, but they're strictly for math majors, and we could do a whole video on that sometime, because that's kind of interesting too.
Awesome. Well, thanks for telling us more about these sort of mid-tier levels, and I guess we'll make another video about the upper ones.
We'll do it.